Introduction to Data Science. This course provides comprehensive introduction to data science, covering fundamental concepts, tools, and techniques. You will explore how data is collected, processed, analyzed, and visualized to make data-driven decisions. Whether you're new to data science or looking to strengthen your foundation knowledge, this course will help equip you with essential skill for working with data. By the end of the course, you will have a clear understanding of data science workflows, machine learning basics, and how data-driven insights drive decision making in various industries. Course objectives. By the end of this course, participants will be able to define data science and understand its role in modern industries, explain key data science concepts, including data wrangling, exploratory data analysis (EDA), and machine learning. Identify common tools and programming languages used in data science, Python, R, and SQL. Understand data collection, cleaning, and pre-processing techniques. Perform basic exploratory data analysis using Pandas and Matplotlib. Explain the fundamentals of machine learning and its real-world applications. Recognize key career paths and job opportunities in data science. The target audience. This course is ideal for beginners interested in starting a career in data science, students or professionals transitioning into data-driven role, business professionals looking to leverage data for decision making, tech enthusiasts curious about AI, machine learning, and analytics. Below are the modules of this course.
Would one of this data science course, where we'll be looking into the introduction to data science on the following units. What is data science? The data science lifecycle and the real world application of data science. Overview of data science. What is data science? At its core, data science is the study of data to extract meaningful insight, often for business purposes. It represents the practice of understanding data and leveraging it to address real world problems. In an era where organizations are inundated with data from many sources like sensors, machines, online interactions, and more, data science provides the tools, methods, and technology necessary to transform this raw data into actionable knowledge. Simply having data is not enough. Data science is the discipline that converts these raw numbers and observations into valuable informations. Characteristics of data science. A key characteristics of data science is its interdisciplinary nature. It is not confined to a single domain, but rather emerges from the convergence of several fields. Secondly, data science majorly blends computer science, encompassing programming skills, algorithms, and data management techniques. Statistics, providing methods for analyzing data, testing hypotheses, and understanding uncertainty. And domain expertise, the specific knowledge related to the industry or area where the data originates, such as healthcare, finance, or retail. This unique combination allows data scientists to clean, combine, analyze, and interpret vast and complex data set to solve intricate problems. Recognizing this blend is important for newcomers as it signifies the proficiency in data science involves developing a breadth of knowledge across these areas rather than just deep expertise in one. Thirdly, it also undergoes the collaborative nature of many data science projects where individuals with different strengths work together. Fourthly, ultimately, the practice of data science aims to answer fundamental questions that drive decision making. This question often falls into categories like descriptive analysis, which entails what happened, diagnostics analysis, which entails why it happened, predictive analysis, which entails what will happen, and diagnostics analysis, which entails why did it happen. Then predictive analysis, which entails what will happen, and prescriptive analysis, which entails what should we do about it. By addressing these questions, data science provides the foundation for evidence-based strategies and action. The data science life cycle. Overview of the data science life cycle. Data science projects, while diverse, typically follow a structured process or workflow, often referred to as the data science life cycle. This life cycle provides a framework for organizing and managing the steps involved in extracting insights from data. It's important to understand that this process is rarely a rigid, linear sequence. Instead, it's often an interactive cycle where insight gained from one phase might necessitate revisiting earlier steps. Having a defined workflow, however, acts as a valuable set of guidelines, helping teams plan, organize, and implement their project effectively. Frameworks that describes data science life cycle. Several frameworks exist to describe this life cycle. Two widely recognized models are CRISP-DM, that is cross-industry standard process for mining data, and OSEMA, which is obtain, scrub, explore, model, and interpret. While differing slightly in their specific phases, they share common underlying principles and provide a structured approach to data science tasks. Synthesizing these frameworks reveals a set of common key stages present in most data science projects, which are: number one, understanding the goal or problem, which is the business understanding. This initial and critical phase involves defining the project's objectives and requirements from a business or research perspective. It requires understanding what the stakeholder aims to achieve and defining clear success criteria. This steps drives the entire process, ensuring the analysis remains focused and relevant. Secondly, getting the data or data collection. This stage focuses on identifying, acquiring, and accessing the necessary data from various sources, such as databases, files, APIs, or web scraping. The quality and relevance of the data collected here are foundational for the project success. Thirdly, preparing the data or data preparation. Raw data is rarely ready for analysis. This stage involves cleaning the data, which involves handling errors, missing values, and duplicates, transforming it into a suitable format, and potentially integrating data from multiple sources. This is often cited as one of the most time-consuming phases in data science projects. Fourthly, explore the data or data exploratory analysis. Before formal modeling, data scientists explore the data to understand its structure, identify patterns, detect anomalies, and generate initial hypotheses. This involves statistical summaries and data visualization techniques. Modeling. Modeling is where algorithms, often from machine learning, are applied to the prepared data. The goal is to build models that can predict the future outcomes, classify data, or uncover deeper patterns based on the project objectives. This involves selecting an appropriate techniques and training the models. Sixth, evaluating. Once models are built, they must be evaluated to assess their performance. and determine how well they meet the initially defined business objectives. These steps help to choose the best model among alternatives and ensure the results are reliable. Number 7, deploying or interpreting. The final stage involves putting the model into production for practical use, or more broadly, communicating the findings and insights derived from the analysis to stakeholders. This could range from generating reports and visualization to integrating a machine learning model into an application. This iterative nature mentioned earlier is crucial. For example, insight from the exploration phase might lead back to collecting more data, or poor results in the evaluation phase might require visiting or revisiting the data preparation or modeling stages. Success hinges not just on technical execution, but on clear understanding of the initial problem and adapting the process as understanding evolves. Real world applications. The impact of data science is widespread, touching nearly every industry and aspect of modern life. Its application demonstrates the power of transforming data into actionable insight and automated decisions. Examples of diverse applications of data science. Here are a few examples that are concise, illustrating its diverse utility. E-commerce and entertainment personalization. Many online platforms leverage data science to enhance user experience. Recommendation system like those used by Netflix to suggest movies or Amazon to recommend products. Analyze past user behavior, viewing history, purchase history, browsing pattern to predict future preferences. These system employs algorithms to identify patterns and deliver personalized contents, driving engagement and sales. Healthcare advancement. Data science contributes significantly to healthcare, from improving diagnostics to predicting patient outcomes. For instance, Google Lima lymph node assistance 2 utilizes machine learning to help pathologists identify metastatic breast cancer cell in lymph node biopsies, potentially increasing accuracy and speed of diagnosis. Predictive models can analyze patient data to forecast disease risk or treatment effectiveness. Transport and logistics optimization. Companies involved in moving goods or people use data science to improve efficiency and reliability. UPS, for example, employs its Orion system, which uses advanced algorithms and machine learning optimize delivery routes for drivers, saving millions of miles and gallons of fuel annually. Airline also use data science to predict flight delays, optimize routes, and manage pricing strategies. Financial fraud detection. In the finance sector, data science play a crucial role in identifying and preventing fraudulent activities. Machine learning algorithms analyze vast amounts of data transaction in real time to detect unusual patterns and anomalies that may indicate fraud, helping protect both financial institutions and consumers. These examples highlight how data science translates data patterns into tangible benefits, ranging from personalized experiences and operational efficiencies to improve health outcomes and enhance security. It is not merely an academic pursuit, but a practical discipline driving innovation and decision making across the field. All right. To perform data manipulation, data cleaning, data analysis, data scientists rely on various software tools in the Python ecosystem. A few libraries are foundational and widely used, particularly for handling structured data. So first thing we're going to be doing is the download of Anaconda. Now, Anaconda is an open source of distribution of Python and R products. So within Anaconda is our Jupyter notebooks as well as a lot of other things. But we're going to be using the Jupyter notebooks. So let's come right down here, right? First thing download. So you can download from here. If you download this graphical installer. All right, so you can actually select under the distribution installer check you're using Windows, Mac, or Linux. I'm using Windows, so I'm going to be clicking here under the just 4-bit graphic installer. So you're going to click on it. Once you click on it, it's going to start download at 12024. So download is gone. All right, so it's going to take about 2 to 3 minutes. Remember, you have to change the bit on your system to the system setting, the 64-bit to keep it. Your download should take you between 2 to 3 minutes. So we're done here. So you click on it. Okay, so once your download is done, like I said, click on this. Once you click on it, it's going to bring up the installer for you, which is right. So you're going to be clicking on next. So once you install it, so install for, I think just needs, okay. It has the installation type, like the type of installation you would like to perform. You will Anaconda 3. If you just use it, just use it. If you have multiple users, you can select it. But we're going to be selecting, that's me, it's just one. So go next. Now it's going to show you where you're going to be installing it on your computer. Okay, so this is the actual file path. So it's going to take about 5.2 gig of space. So I have plenty of space. Make sure you have enough space before you install it. So what did you do? We can come over here, right? Next. Now we can do some advanced installation options. So we can add Anaconda 3 to my path environment variable. So we're using Python. We can have a default path with whatever your Python IDE or notebook that you're using. So because of the possibility of using a lot of visual codes, right? Anything we do, you might be careful with it so you don't mess things up. And then for this add Anaconda 3 to my path, it says it's not recommended. See that? Not recommended. So messing with this path is kind of something you might want to do once you know more about Python. I don't really recommend you to I can't recommend you having the checks, right? You can register Anaconda 3 as my default Python 3.12. You can do this on one, I'm going to keep it right this way. So I have the exact same set it as you do. So let's go ahead and click install. And now it's installed this on your computer. So it's going to add completion. So we're going to head to the next thing to be done. So set it up in the package. All right. It's still installing, almost 3 seconds left. So to get it all wrapped up with and move to the next aspect of this installation process. Now, once we complete it, you can click next again. If you want to, you can add the launch Anaconda navigator or the train. But if you like to add it, you can launch them. But I don't, but click finish. So we're done. So let's go down and click for Anaconda. So we have Anaconda navigator. So we're going to click on that. All right, with login. Okay, like I'm doing the first time. Checking about. So it might not be all of this or see your system releasing the Omra update, but this will updates up to the latest, the last latest update that they are out. So it's still loading. I'll do because of it's of my system. I installing it after fresh from the system, right? So we have it loading. But we have but using the details. Oh, that is one distribution of Python in R. But we're gonna be adding import option here. Some might be familiar here, right? We have Visual Studio Code, Spider, and we're supposed to have one more. We're supposed to have a Jupyter notebook. So we have the them. So right here we have our Jupyter notebook. So let's go ahead and click on launch. So this was the pop up on your right now. You can take most of it at the go forwards. So we're going to be opening a new tutorial notebook where we're going to be learning a lot of future code writing and tutorials. So you can use these areas to save things, to create folders and organize things, all of that. So if you have notebook from previous projects, you can upload it from here. We're going to be checking. So we're going to be copying up a Python 3. So when you click on new and click on Python 3, it fed out. It's going to bring it here. But we're going to be having most of our work done, right? So this is a cell. So let's do something in the cell, right? And print is the famous hello world. Print hello world. So first it's shift. We're going to click on shift, enter. So you have your hello world. If you had that something else, you see that it had it reflected, right? So we're running by clicking shift, enter. And that is where all of our the code is going to go, right? These are code cells. Speaking, these are code cells, and we have it on start over here. We're going to get to that. One thing I want to show you is that you don't have to really write code here. You can also do something called Markdown, right? Markdown is its own kind of, you could say, language, but it's just a different way of writing, especially with notebook. So I'm going to do with you to is Sharon. Where's the a moment, please? Different way write like merchant. Hashtag. I'm gonna do hashtag. Whatever I do as first. Oh, right. Just like here, I'll do that. So, hello, these are actually very important. For investor that is actually what it is. Actually save it fix, right? If you want to please then tie to you. Sorry, long please. So you can save to here. If you want to can type do also to look like X, X, Y, Z, you know, those. So we can go ahead right here. X, Y, Z, you know. So where is it? Imperatives. Over here you can see the X, Y, Z new changes of the book well. That means it's currently running, right? So we can run in X right up here. And we don't want it to, we can turn it down right there. You know, we do work, we would run the code anymore, right? So we're gonna run up a new cluster, right? So let's do that. Let's do it. That all. Oh, here another notebook running, right? So if I have a little bit, another little bit writing, just take care of deliver this. You don't make her in handy, sir. You can also delete cells. So on and have code here. And here have code there. So once you remove this, you can just do this. Right? You can get rid of it by just using the code selected cells. You can also copy selected cells. So you can copy selected cells. You can come around here, the pit selected cells. Right? Paste our packet cell. Get out a little bit to define the kit what you want them to be, right? Different views offsets that I have here. Just do a lot of things. So here I hit shift enter, right? We here we're going to work on a code, right? So clicking shift enter, you can just click on run this cell and pass, right? If you're working multiple codes that is actually remote here and it's not working properly, you can stop that by doing interrupt right here. And if you're trying to do within this corner, if it's not working properly, it will stop, right? You can restart it and you can try fixing your code. If also it does but you're trying to restart your corner, Like this one, if you want to restart the kernel and rerun the entire notebook. And we talk about it. So a second ago, we have our code, a markdown code, right? Thank you. So the next thing is right up here. If you click on file, you can create a new notebook. Sorry, you can create a new notebook. You can create existing notebook at all. Data actually, you can do a lot of things we're talking about here. Things you want to do, undo, redo, cut, copy, set, view. You can add a lot of features on the view you prefer, right? So I'll go on. Now, all that's set, right? And we can actually really enjoy, right? Oh, and now that we worked through all that, we now have the Anaconda and Jupyter notebooks installed on your computer. In other future videos, this we're going to be writing all I could be the code to write. Thank you very much. See you in the next video.
For watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.
Welcome to Module 2 of this data science course, where we'll be looking into data collection and processing under the following units. Data sources, structured versus unstructured data. Data cleaning and pre-processing, and introduction to tools such as Python, Pandas, and NumPy. Data sources, structured versus unstructured data. Brief overview of data sources. Data, the raw material for data sciences, originate from countless sources and exist in various forms. Understanding the fundamental type of data is essential for collection and processing. The two primary categories are structured and unstructured data. Structured data. This type of data is highly organized and conforms to a predefined format, typically residing in tables within relational databases or spreadsheets. It consists of clearly defined data types like numbers, subtext strings, and dates, arrays and rows and columns because of its organization. Structured data is generally quantitative, measurable, or easily categorized, and relatively easy to store, query, search, and analyze using standard tools such as SQL. Examples are ubiquitous in business systems and includes customer records in a CRM, which includes names, addresses, phone numbers. Financial transaction logs, point of sale data, dates, and stock market. Unstructured data. In contrast, unstructured data lacks a predefined data model or organizational structure. It does not fit neatly into rows and columns and is often stored in its native format, frequently in large repositories known as data lakes. These categories include a vast array of information, often text-heavy or multimedia in nature, such as emails, social media posts, text documents, images, audio recordings, and video files. Sensor data and machine logs can also fall into this category. Unstructured data is typically qualitative and present significant challenges for searching, processing, and analysis, often requiring specialized tools and techniques like natural language processing for text or computer vision for images to extract meaningful information. Semi-structured data. It is also worth noting that the existing or existence of semi-structured data is also another aspect of categories of data, which falls between the two extremes. This data doesn't conform to the rigid structure or relational databases, but contains tags or markers to separate semantic elements and enforce hierarchies of records and fields. Common examples include data in JSON, that is JavaScript Object Notation, or XML, Extensible Markup Language formats, as well as emails which contain unstructured content alongside structured metadata, which includes sender, recipient, and date. A critical point for aspiring data scientists is that while structured data provides easier entry point for analysis, a vast majority of data generated today is unstructured. Therefore, developing skills to handle and extract value from unstructured data is increasingly important for tackling complex real-world data science challenges. Data cleaning and preprocessing. Real-world data is rarely perfect. It is often described as messy. Data collected from various sources can be incomplete, contain errors, inconsistencies, information, irrelevant information, or duplicate entries. This process of identifying and correcting these issues is known as data cleaning, a crucial part of the broader data processing phase. The adage, garbage in, garbage out, which is known as GIGO, strongly applies here. Feeding inaccurate or poorly prepared data into analytical models will inevitably lead to unreliable results and flawed conclusions. Consequently, data cleaning and preprocessing are fundamental steps, often consuming a significant portion of a data scientist's time, but they are essential for ensuring data quality, integrity, and the validity of any subsequent analysis. While specific techniques vary, the core conceptual steps involved in cleaning and preprocessing data typically include: number one, handling missing data. Data points can be missing for numerous reasons, which includes errors during collection, non-responses, or data simply not being available. Ignoring missing data is often not an option, as many algorithms cannot process incomplete datasets. Common approaches include deletion, that is, removing rows or columns that contains missing values. This is simple but should be done cautiously, as it can lead to significant loss of potentially valuable information. Imputation, filling in missing values with estimated ones. Simple methods involve using the mean, median, or mode of the respective column. More complex methods might use predictive models to estimate the missing values. Imputation preserves data points, but introduces estimate values, which might affect analysis integrity. Understanding why data is missing, for example, completely random versus related to other variables, can help choose the best strategy. Secondly, removing duplicates. Duplicates record can arise especially when combining data from different sources or due to data entry errors. These duplicates can bias analysis. That is, for example, overrepresenting certain instances and should be typically identified and removed. Thirdly, fixing structural error. This involved correcting inconsistencies in the data structure or format. Examples include typos in categorical labels, inconsistent naming conventions, for example, USA, United States, US, incorrect capitalization or standardizing date formats. These errors can cause data points to be incorrectly categorized or analyzed if not addressed. Fourthly, handling outliers. Outliers are data points that lie significantly far from the majority of other data points. They can be caused by measurement errors, data entry mistakes, or represent genuine, albeit extreme, values in the data. It is crucial to investigate outliers to determine their validity. If an outlier is confirmed as an error, it might be removed or corrected. If it's a valid but extreme value, the analyst might choose to keep it but use statistical methods robust to outliers to analyze it separately. Number 5, data transformation. Introduction. Sometimes data needs to be converted into a different format or scale to be suitable for specific analysis, techniques, or algorithms. This can include encoding categorical variables, for example, like red, blue, green, into numerical representation, or scaling or normalizing numerical features so they fall within a specific range, for example, 0 to 1, which can be important for algorithms sensitive to feature scales. It is vital to recognize that data cleaning is not merely a mechanical checklist. The appropriate methods depend heavily on the specific dataset, the context of data, and the goal of the analysis. It requires careful examination, critical thinking, and information judgment calls at each step to ensure the final dataset is both clean and representative. Introduction to tools: Python, Pandas, NumPy. To perform data manipulation, data cleaning, data analysis, and data modeling, data scientists rely on various software tools. In the Python ecosystem, a few libraries are foundational and widely used, particularly for handling structured data. A. Python. Python has emerged as a dominant programming language in the data science community. Its popularity stems from its relative simplicity and readability, making it accessible for beginners, combined with a vast collection of powerful libraries specifically designed for data analysis, scientific computing, visualization, and machine learning. It serves as the primary environment for tasks ranging from data preparation to building complex artificial intelligence models. B. NumPy, which is known as numerical Python. NumPy is a fundamental package for numerical computation in Python. Its core contribution is the int array, that is, n-dimensional array object, which provides an efficient way to store and operate on large data sets of numerical data, such as vectors and matrices. A key advantage of NumPy is its support for vectorized operations, which allows mathematical functions to be applied to entire arrays at once, rather than element by element in a loop. This leads to significantly faster execution speeds compared to standard Python lists, making it crucial for performance-intensive calculation, common in data analysis and machine learning. Pandas. Built upon the foundation of NumPy, Pandas is the primary library for data manipulation and analysis of structured data in Python. It introduces two essential data structures: the series, which represents a single column of data, and data frame, which represents a two-dimensional table with rows and columns, akin to a spreadsheet or SQL table. Pandas provide extensive functionality for reading data from various formats like the CSV files, Excel spreadsheets, SQL databases. Cleaning data, handling missing values, filtering rows, transforming data, which includes handling columns, reshaping tables, merging data sets, and performing exploratory analysis. Its intuitive structure makes working with tabular data much more manageable. For beginners, The focus should be on understanding the purpose of these tools within the data science workflow. Python as the language environment, NumPy for efficient numerical operations on arrays, and Pandas for versatile manipulation of table data. These libraries often work together, forming a core part of the Python data science toolkit. Mastering the basic usages fundamental steps towards practical data analysis. Below are recommended resources for further learning in Module 2. In conclusion, data science exists in structured, organized, and tabular, and unstructured, which include lacking predefined format or fonts. Raw data is often messy, necessitating crucial cleaning and pre-processing steps, like handling missing values, duplicates, and outliers to ensure quality. Python, along with libraries like NumPy for numerical efficiency and Pandas for tabular data, are fundamental tools. We've come to the end of the Module 2 of this data science course, where we learned about data collection and processing under the following units: data sources, which includes structured and unstructured data, data cleaning and pre-processing, and introduction to tools such as Pandas, Python, and NumPy. In the next module, we will be delving into exploratory data analysis.
Thanks.
We'll be taking a look at functions in Python. So a function is a block of code which is only run when you call it. So there's way to define functions. So right here is the way to define function. And so right here, we're defining our function, and this is a body of code that when we actually call it, it will run. So right here, we have our function call. How we are doing is to put in the function with parentheses. That is basically calling out that function, like we calling that function, right? And then we have our output. So we're going to be showing you how to write a function as well as pass arguments in this after aspect of the video. So how to pass argument to our function, and then a few other things like arbitrary arguments, keyword arguments, and arbitrary keywords. All these things are really important to know when you're using the functions. So let's get started by writing our very first function together. We're going to start off by saying df, which is a keyword defined in function. Then we can actually name our function. So for this, we're just going to do first underscore function, right? Then we'll do an open parenthesis. So put a color and hit enter. Sorry to all of it. Sorry. Enter. Now, the mistake I made is hit shift enter. Now, you're not supposed to hit shift enter to bring up a syntax error, right? So let's do this again. So now, now you're supposed to just hit enter, which automatically index or rather intent for us. And that is where our body of code is going to go. Now, within our body of code, we can write just about anything. And in this video, we're not going to be doing any advanced stuff. We're just going to walk through basics to make sure that you understand how to use functions. So right now, what we're going to be saying is just right. You open your parentheses. Then we'll do an apostrophe. And then we say, we did it. And now we're going to be hitting shift enter. Now, it's not going to do anything. At least you won't see any output from this. But if you want to see the output, or we actually want to run that function, and some functions don't have outputs. But if we want to run that function, what we have to do is just to copy this. Put it back here. And we're actually going to call our function. So let's go ahead and click shift enter. And now we'll successfully call our first function. This function is about as simple as it could possibly be, as simple as it could possibly be. But now let's take it up a little bit up a notch. Let's start looking at arguments. So let's go right down here. We're going to say, so find number square. We'll do parentheses and a color as well. The column as chemical. Okay. Now, really quickly, when you're naming your function, it's kind of naming a variable. You can use something like X, Y, but it should be more, try to make it more descriptive, right? So let's take a look at passing an argument into a function. The argument is going to be passed in the parentheses. So for us, we're going to call it number. We're going to hit enter. And now we'll write our body of code. So what we're going to do for this type of range, and open parentheses, I would say number, sorry there, number, do the 2 stars, okay. Now what this is going to do is that it's going to take the number that we pass into our function, it's going to put it right there in our body of code. And then from what we're doing, it's going to put it to the power of 2. So when the user or you or anyone run this and call this function, this number here, it's something that you can specify. It's an argument that you can impute that will then be run in this body of code. So let's copy this right here. You pull it right out here into the snapshot, and then we say by. So this file is going to pass through into this function and be called right here for this track step length. Let's run it. It could come out as 25. Now, this is my code. I forget to actually run in the block of code. So then it's, I'm gonna hit enter. Okay, now we define our function operation where we didn't define it actually before. And now we can actually call it so. Now we'll hit shift enter. Okay. Now what comes now? We have to look through it for any issue. Don't be scared of errors or syntax errors as it is. Just look through what you haven't included or added. So this hasn't run, hit enter, number, square, 5, okay, leg it off, and we have 25. If you have semicolon, just read through every error so you can have a very viable output, which is for this case is 25. Now in this function, we only called one argument, but you can basically call as many arguments as you want. You just have to separate them by comments. So let's copy this and put it right down here. Now we say number squared underscore cost. And the new number, either we have the value to power. And now we can specify our lower as well as the power we want to raise it to. So instead of adding Q, which is what you call accolade, we can now customize that and we'll have power, and then we call this function, we can specify, okay, so we'll have a specific amount of power. So what we call this function, we can specify the number and the power, and both of those we go into exploit mode. And we route and we customize those numbers. So let's copy that. Can I move this 5 to the power of 3? And let's look for, we actually run this shift enter, right? Now we can call our function this equal shift enter. And we've got 5 to power 3, which is 125. And just one more last thing to mention is, if you have 2 arguments within your functions, call it a right here, you have to pass a 2 arguments. You can just add 1. So if you have a 5 right here, it's going to be error. So for example, third part is extract under it. Sorry, see that? It's going to be an error. We have to specify both arguments for it to work. So let's add 3. You have 1 to our part. So let's take a look at arbitrary arguments. Now, arbitrary arguments are quite interesting because you don't know how many arguments you want to pass through. If you don't know if it's 1 or 2 or 3, you just specify that later when you call in the argument. So you don't have to do it up front and know that information ahead of time. So let's define our function. Okay, let me add more cells to this. So just say define. Say number underscore adds. It will do an open parenthesis and a colon. Within our argument right here, typically we just specify here what argument will be. It will be number or it will be a word. We're going to be doing is something called an arbitrary argument. So it's unknown. So we're going to put star. Star, we're going to take fact. Now, you will see something exactly like this. Typically, if you're looking at tutorials, they'll add star arcs in there, or if you're looking for just a generic piece of code, this is what it will look like. But for us, we're going to actually put number. So again, we have the star, and then we have our arbitrary argument right here. Then we hit enter, or maybe could say blank open parenthesis. So then we're going to get a little bit different. We're going to take number from bracket and say 0 and say times. Okay. I'm going to do that times. Say with per part. So when we run this and then we call this number x function right here, we're going to need to function right here. We're going to need to specify the number 0 and the number 1 that's going to be called. Go ahead and run that. And we'd like to call it, let's say 5, x, 1, 2, 8. So right up here, we know how many arguments we're going to pass to. It could be 5, it could be 1,000. We could also call in a pickle, and that's what it is right here, calling a people. So what it's going to be now is when it called this number, it's going to call the very first within that tuple, which would be that 5. And then it will also call this number, which will be the first position, which is the 6. So that's 8, 2. So it's going to multiply these numbers together as 5 times 6, which is equal to 30. Now, like I just said, this is a triple. So this is a triple. So we don't actually have to write out these numbers like we just did. We then pass through a triple where we actually calling this function. So let's do that right out here. And we just create x. X in this country. Few open parentheses. We do just just copy it from here to make it easier. Now produce before right here, which we can then pass in. They'll be a lot more handy, a lot more specific, and this is most likely how someone will do something like that. But let's now create that. Now can copy x tuple. And pass through. So just so you know, this is going to fail. It's on purpose, but when to show you so you know what you need to do in order to pass through this tuple. So that's why, right? So right now it's gonna say, sorry, Google index and all of that is algorithmic, but it says our tuple is not defined, right? But in order to use this, you have to specify a term for it. Just like you did while we're creating your argument hop here. The output got to start in front of our tuple that we just passed. Now let's run it again. Fine. Why do you still have that? Okay. Number heads. So why do we still have error? So remember here we have only going this. So you run it shift enter. So when you come back here now, you just enter, and now it works properly. So that will be all for the functions in Python, which we can still look at in the future videos, keyword arguments and arbitrary keyword arguments. But let's check that now. Yeah, let's check that now. So in the other videos, we're going to advanced learner. So there are more things you can learn or do within the functions, but again, just to learn the basics, make sure you ultimately understand how they work. So let's go wrap up here. So a keyword argument is kind of similar to this wrap up here. Put on it. So let's cover this. Now, keyword is right. Okay, keyword is very similar in that you're going to specify your arguments right here. What we do over here. Oh. So when I move it up here, is this house. So we'll actually call the function. What we did was to just put it 5 and a 3. And we'll do that it automatically assign the number 5 and the power of 3. And that's totally okay. You can do that. But if you want a little bit more control, you can use a keyword argument. So right here, we could say power is equal to 5. 5. The number is equal to 3. So I just switched it around. Right number was assigned to 5 and the power was assigned for 3. I just switched it to show you how this might work. So let's run both of these. Notice. So we have an error again. So what could be the concern? Now, what could be the concern? We have to do that. So let's do that again. So this is actually case sensitive. Remember in the beginning video, we mentioned that this can be quite case sensitive. So my keywords and cultural error. Let's run it to see if there'll be another error again. Right? Yeah, you can expect a keyword argument. We're going to put it back to where it was. So let's run it again. And now it's 3 to the power of 5, which is 243. That's 243. So that essentially is a keyword argument. Again, it just gives you a little bit more control. You don't have to put them in specific positions, like you can just calling multiple arguments. So let's go down right here. That's our motels. We'll go right here. We're going to create basically another custom control. So for this one, we're going to write define number underscore quag. It's parenthesis and a colon. Hit enter. Now this was the keyword argument or an arbitrary keyword argument. Now to specify an arbitrary argument, all we did was a star and then we impute none. But if you're doing a keyword argument, we actually have to add 2 stars right before we impute number. So right here, 2 stars. Okay, we're doing dented, but it didn't. Something is wrong. So you just make column, not a column. Now, these errors that you kept seeing and I keep correcting are the feasible and possible errors you encounter alongside errors like the case sensitivity, a colon, semicolon instead of colon instead of semicolon, colon, all those little colons, using a semicolon instead of a colon, right? Now, clicking enter on this will automatically incant this for you, right? Now, let's start taking a look again. And if you're doing arbitrary, it means we don't really know how many keywords argument we want to pass into our function. So we're just going to put that's the number and then later with our body of code and what we call it, we'll be able to specify. It's just like the arbitrary argument before the arbitrary keyword argument means where you just don't know how many keywords argument we're going to need to pass into our functions. So to demonstrate this, let's write print. We can create this. We say my sorry, I'm supposed to do an apostrophe. Straight. I do guess. So when I do that, let's say face, I'm gonna just plus, spec plus. So this way it gets a little interesting or a bit more tricky. So we're gonna say is number. Is this semicolon is supposed to be here? Supposed to be here. So plus number. So this is us calling our number, and then we're gonna do a bracket, and then we're going to go to calling the function. It's a little bit backward. Or a little bit different than what you might think. But what we are calling it, what we're going to do is we're going to say integer sequence explode random number, right? So what we're calling that keyword within a body of code, what we're going to do, what we're going to do is we're going to actually type up integer. Just like this. This is a little bit different, but what this allows us to do is we can put as many keyword arguments in here as we want. We'll show that later. Okay. For us, we just retain this key and this value when we're calling it within the function. So now, what we create is when we run this, most likely do the error. What was this? Yeah, we have. We have an error. You know why? This is supposed to be in the print. So let's run it again. Like I said, every error is assigned to show you what you can do wrong and how best to do it. So let's try it again. Obviously having that. Obviously having error. So what didn't we do now? So it's not defined. So it means I will run that here. So let's run it. Now we write here. Now let's run this again. Let's go through now. Right? Now we'll say my number is 309. We're gonna add plus. Now it does not make it look great, but let's say my other number. Okay. So, okay. So right. Okay. My other variable say number. And we specify again what we want in there. So you can go down here to where we're calling it. We could say integer is equals to another random number. Yeah. So we had the plus right here. So we want another here. So we create this. Remember this number. So we right. We created posts. Well, we run with it. Now, see both numbers pass through, right? Again, the syntax is terrible, but now you can see that you have this arbitrary keyword argument right here, and all we have to do is put numbered, and we can pass through as many of these arbitrary keyword arguments as we want. I don't know if we just specify it within our component or record it. Okay, so that's all we're gonna look at today's explanation of functions. There are other things that you can do with functions, and they can get a little bit more advanced, but we're just going to show you that this is just an introduction to these basic functions. Thank you.
For watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.
Welcome to Module 3 of this data science course, where we'll be looking into exploratory data analysis, EDA, under the following units: understanding data sets, data visualization techniques, using matplotlib and Seaborn, and statistical summary and insight. Understanding data sets, the goal of EDA. Exploratory data analysis, commonly known as EDA, is a critical initial phase in the data analysis process. It involves examining the data sets, often using visual methods and summary statistics, to understand their main characteristics, uncover underlying structures, and extract key insights before applying formal modeling techniques or drawing definitive conclusions. The fundamental goal is to become thoroughly familiar with the data. Purposes of exploratory data analysis. The purpose of exploratory data analysis is multifaceted. It aims to A. Uncover patterns and trends. That is, identify relationships between variables or trends over time that might not be immediately obvious. Spot anomalies and outliers, which involves detecting unusual data points or errors that could affect analysis quality. C. Test initial hypotheses. Check assumptions about the data and formulate preliminary hypotheses based on observation. D. Assess data quality. Evaluate the completeness and correctness of the data, informing necessary cleaning steps. E. Extract important variables. Identify which features in the dataset seem most relevant to the problem being investigated. F. Inform modeling choices. Insights gained during EDA can help guide the selection of appropriate statistical methods or machine learning algorithms for later stages. Exploratory data analysis is crucial because it lays the foundation for robust and meaningful analysis. By thoroughly exploring the data first, analysts can avoid pitfalls caused by poor data quality, make more informed decisions about subsequent steps, and ultimately produce more accurate and reliable results. It is best viewed not as a rigid set of procedures, but as an iterative cycle and a state of mind characterized by curiosity and investigation. This cycle involves generating questions about the data, seeking answers through visualization and transformation, and using the findings to refine existing questions or generate new ones. Two fundamental questions often guide EDA, which are: what type of variation occurs within my variables, looking at individual features, and what type of covariation occurs between my variables, looking at a relationship, the variation and covariation. Data visualization techniques. Overview of data visualization. Data visualization is a cornerstone of exploratory data analysis. It involves representing the data graphically through charts, plots, and maps, transforming potentially complex numerical information into easily understandable visual formats. This visual representation makes it significantly easier to identify patterns, trends, relationships, and outliers that might be hidden within raw table of numbers. Visualization serves a dual purpose. It aids the analyst in understanding the data during the exploration phase, and it provides a powerful means of communicating findings and insight to others, including non-technical audiences. In the Python ecosystem, Matplotlib is a foundational library that provides a wide range of tools for creating static, animated, and interactive visualization. It offers detailed control over plot elements. Seaborn is another popular library built on top of Matplotlib. Seaborn specializes in creating statistically informative and aesthetically appealing plots with simpler syntax, making it particularly well suited for common EDA tasks. For beginners, focusing on a new fundamental plot type is key, such as histogram. The purpose of histogram is to visualize the distribution of a single numerical variable. It shows how frequently different ranges of values occur within the dataset. How does it work? The range of the variable is divided into intervals called bins, and a bar is drawn for each bin. The height of the bar represents the amount of the count or frequency of data points falling into that bin. Interpretation. By examining the histogram, one can understand the central tendency where data clusters spread, how wide the distribution is, shape, symmetric, bell-shaped, skewed, left-right, bimodal, and identify potential outliers, which are isolated bars. Conceptual examples is an histogram of students' exam scores, which might show that most scores cluster around 70 to 80, with few students scoring very high or very low. Scatter plot. The purpose is to visualize the relationship between two numerical variables. It helps determine if there is a correlation or pattern between them. How it works. Each point on the plot represents a single observation. For example, one person, one day, with its position determined by its value on the two variables plotted on the x and y axis. The interpretation. The overall pattern of points reveals the nature of the relationship. Positive correlation. Points tend upward from left to right as one variable increases, the other tends to increase. Negative correlation. Points trend towards left to right as one variable increases, the other tends to decrease. No correlation. Points are scattered randomly with no discernible trend. The tightness of the point around the potential trend line indicates the strength of that relationship. Outliers appear as points far removed from the main cluster. Statistical summary and insights. Alongside visualization, basic descriptive statistics provide numerical summaries of datasets, key characteristics, completing the insights gained from plots. These statistics, particularly measures of central tendency, help quantify the typical or central value within a distribution. Understanding these simple measures is fundamental for summarizing data effectively. The three most common measures of central tendencies are mean. The mean is the arithmetic average of a data set. It is calculated by summing all the numerical values in a data set and dividing by the total number of values. The characteristics. The mean uses all data points in its calculation. However, it is sensitive to outliers, extreme values, which can significantly pull the average towards them. Secondly, median. The median represents the middle value in the dataset that has been ordered from least to greatest. Calculation. If the dataset has an odd number of observations, the median is the single value in the middle position. If there is an even number of observations, the median is the average of the two middle values. Characteristics. The median is less affected by outliers and skewed data compared to the mean. This makes it more robust measure of central tendency. For distribution that are not symmetrical, such as income data, where a few very high earners might inflate the mean. 3. Mode. A definition. The mode is the value that appears most frequently in a dataset. Calculation. It is found by counting the occurrences of each value and identifying the values with the highest count. Characteristics. A dataset can have one mode that is unimodal, two modes that is bimodal, multiple modes that is multimodal, or no mode if all values occur with the same frequency. The mode is the only measure of central tendency that can be used for categorical data or nominal data. For example, the most common eye color. It is not influenced by extreme values. These three measures offer different perspectives on the center of a dataset. The relationship between them can also provide clues about the data distribution in a perfectly symmetrical distribution. The mean, the median, and mode is approximately equal. Understanding these basic statistics and knowing when each is most appropriate is crucial for interpreting data accurately during exploratory data analysis. Below are recommended resources for further reading on Module 3. In conclusion, EDA is the process of investigating data using visualization like histogram and scatter plots, and basic statistics like mean, median, mode. To understand its characteristics, find patterns, and generate insights before formal modeling. Alright, so in this video, we're going to be talking about data types in Python, right? Data types at the classification of the data that you're storing. These classifications tell you what operations can be performed on your data. So we're going to be looking at the main data types within Python, including numeric, sequence type, set, Boolean, and dictionary. So let's get started by writing some of this out. And first, let's look at the numeric. There are three types of different types of numeric data types. We have integers, float, and complex numbers. Let's take a look at integers. So an integer is basically just a whole number, whether it's positive or a negative. So an integer could be a 12, and we can check that by type right on here. Child type or circumference, open parenthesis, close parenthesis, type 12 is going to give us integer. If you also say a negative, right? It's also an integer. So we can also perform basic calculations like minus 12 plus 100 plus 100. It also tell us it's an integer, right? So whether it's just a static value or you're performing an operation on it, it's still going to be that data type if those numbers are all numbers, whether negative or positive. Okay, so now let's take this exact examples we used here. Hold on, please. Let's say 12 minus 12 and 12 will do plus 10.35. So what we run this is no longer going to be a whole number. It will now be a float. So let's check it. Shift enter. Now this is a float type because it's no longer a whole number, it's now a decimal. And the last data type within the numeric data type is called complex. So let's copy this right here. Let's paste it. Sorry. Let's paste it here. Sorry. Let's do a protocol. Ouch. Okay. So let's say 12 plus 3j, after 12 plus 3j. Looking to hence, it's going to give us a complex. So a complex data type is used for imaginary numbers, right? So if you're going to be using complex for imaginary numbers, in this case, j is going to be that imaginary number. So if you use something like c or any other number, let's see, it's going to give you an error if you use c. J is the only one that will work with it, right? So let's take a look at Boolean values, right? So Boolean data types only has two built-in values, either true or false. So let's go right down here. Let's say type parenthesis close parenthesis true. And when we run this, it's gonna say boot. Sorry, the moment please. It's true, not type. So when we run it, moment please. Okay, typing true. Let's run that again. So it's gonna say boot, which stands for Boolean. So we're going to do the exact same thing with false. But that's also Boolean. A moment, please. False. That's also Boolean. And this can be used with something like a comparison operator. So let's say, a moment, let's say 1 is greater than 5. Let's check it. It's taking out the Boolean because it's telling us whether 1 is greater than 5. So let's bring that right down here. Now here, let's run them. This would give us a false, so it's telling us that 1 is not greater than 5. And just as we got the false, we can say 1 is equals to 1. Sorry. 1. And then you give us a true. Sorry. Let's run that arcade. That's to 1. If you give us true now, give us true. Right. So now let's take a look at our sequence type data types. And that includes string lists and tuples. So we'll start off by looking at strings. Okay, let's type the theme. So in Python, strings are arrays of bytes representing Unicode characters. When you're using strings, you put them either in a single quote, a double quote, or a triple quote, which you can also follow apostrophes. Right? Most people who use Python code and quotes. So here we have a single quote. Single quote. Single quote. That works well. And we can also do a double quote. And that works also. And as you can see, they're exact same output. And then we have a triple quote. So triple quote, then like this. And this is called multi-line, right? So meaning it, we can write for multiple lines here. So let's write a nice little poem, right? Let's say the donuts disappeared while I still while I'm searching for ticket. As a result of my eyes flashed with inspiration. And just a point there. Inspiration. As it no longer exists on Thursday. So if we run it, it's going to look actually a little bit weird. It's basically giving us the raw text, which is completely fine. But let's call this auto. Okay, but like here, more drop. So we're going to call it this variable motor. We're going to be calling it variable multi-line, and we're going to be calling down here to say point, right? Wait, think how ball got it. All right. So say this. So let's bring our multi-line. So let's see. And now we have our nice fun right down here. Now, something you need to know about the single and double quote is how they're actually used. If we use a single quote, I would say, I am always a moment, please. Okay. I'm always what happens. Oh, sorry. I wanted to always. I've always wanted to get him gallon of ice cream. So we put a full stop. Oh, do it. Doing a push and obviously something went wrong here. Right? So overall, it's going to use a single code within your text. In your sentence, you have another apostrophe. It's going to give you an error. So like I was saying, so there will be error. So what variable is when you use a single quote and then within your text or within your sentence, you have another apostrophe right here. It's going to give you an error. So what we want to do is whenever we have a quote in it, we need to use a dot code. This dot code will negate every single code you can have within your statement, like we have here. They will, however, negate another dot code. So you need to make sure you aren't using a dot code within your sentence. If you want to do something like that, you need to use the triple quote like I did here myself. So you can do double, right? Okay, ma'am, please. Say you want to have double quotes within your sentence. Still like this. So you keep just add it. Anything you do within this triple quote will be completely fine. As long as you don't do triple quotes within your triple quotes. So you get right. So in triple quotes within your triple quote like this, it's wrong. Hacker, the it's wrong. So it doesn't work exactly again. You just have to understand how it works. But off. You just have to use the proper apostrophes or quotes within your strings. So just to check this, more brief, let's run this. You have that. So just to check this, we can always say, here is our multiply, and we can always say more brief. And it's still a string, right? One really important thing to know about strings is that they can be indexed. Indexing means that you can search with it and that index starts at 0. So let's go ahead and create a variable called this status and click. Okay, let's get here. Let's create a variable and we can say a is equal to, let's say the popular hello code. Hello code. So let's run this. Longer price that straight. Element straight. Okay. So we can say we're going to do a bracket. The same bracket. Sorry. So now we can pass throughout our string using the index. So all you have to do is to do a color. We can say 5. What it's going to do is going to say 0 positions. 0 all the way up to 5, which should give us the old hello, I believe. Let's run it. Right, you have that. So let's run it. Hello. And it's giving us the first 5 positions of the string. We can also get rid of the colon and just say something like let's run it. It's actually going to give us position 5. So let's have it from here, right? 1, 2, 3, 4, and then we have the strings. That's 5. So what did we do here? We count on 0, 0, 1, 2, 3, 4, 5. So 5 is the space. Let's do 6. So you see the actual letter. So let's run it. So that is our W. We can also use a negative when indexing through our strings. So we could say -3. and then to give us the L because it's negative 1, 2, and 3. So we also specify a range if we want to use the default or C. So default will be 0 to 5, and it started at 0 because that was our default. But we could also do 0 to 5. Let's see. Let's run it. So we go with these button 0, 1, 0, 1. So we have L as 2, L, 3, O, 4, and the string is at 5, right? But we can also multiply strings and we can add this L word. So let's do if A times 3 give us L word 3 times, right? And we could also do A plus A, like have more this. I will do A plus, sorry, A plus A. That's L word, L word. So let's take a look at lists. Lists are really cool, fantastic, because they store multiple values. The strings are stored as one value, multiple characters. Lists can store multiple separate values. So let's create a very first list. So let's say that we open a bracket. It means this is going to be a list. The bracket means this is going to be a list. There are other ones like a weekly bracket like this, and the parentheses include family as well. These denotes that there are different types of data types. The bracket is what makes a list. Right. So it is super simple. Saying 1, 2, 3, 3. And we'll run this. Now we have a list that has 3 separate values in it. The comma then this denotes that they have separate values. A list is indexed just like a string is indexed. So position 0 is this one. Position 1 is the 2 and position 2 is the 3. But to create again, so position 0 is this 1. Position 0 is this one. Position 2. Position 2 is a 3. One up to 0, one position 2. Right? Position 3 is a 3. So 0, 1, 2. So now how we made this list, we didn't use any codes because these are numbers. But if we wanted to create a list with string values, we have to do it with our codes. Something like codes, cookie dough. And we'll do a comma, separate the values. Sorry. They'll say Control, very. Let's add one more. Start comma. Now, you notice I did something. Now, you're not supposed to actually put another code within. You just continue your lists. You have to do that. You can't just store a comma, add in here code, and hit play. So, okay. So, when we run this, we have all three of these values stored in our list. Now, one of the best thing about list is you can add any data type within them. They could just have to be numbers or strings. You can basically put anything you want in there. So let's create a new next. So let's say then we do three. Then we have a list. Remember I said you do that in the other one. No, let's add it to it. So comma. Sorry. Be a comma and full stop. Comma boom. Put that on the list. Put how to do the value of true for boolean. So how are we shift enter? We just created a list with several different data types within one list. Now let's take this one right here with all our different ice cream flavors. So I'm just going to say iris underscore cream is equals to by this list. Now, one thing that's really great about list is that they are changeable actually. That means we can take the data in here. We can add and remove items from the list after we've already created it. So let's go and take ice cream. And say, okay. So the fix is, so this is going to append it to the very end of the list. We'll do, okay, open parenthesis. So let's say sound come. While we run this, I want to so what we run on this, and we call it just like this. If you're gonna take this list, add sort of carbon to the end, and okay, I'm waiting for it. So it's going to take this list, add some other comma to the end. We'll print it off. You can see it. As you can see, it was added to the list. And just like it was mentioned before earlier, then we could also change things from those lists. So let's say ice cream. And then we need to look at the index prediction. So we can say it's 0. So that way to be test cookie and go right here. So here we can say that it's port to, so we can now change that body. Let's call it butter cake. All right. Now we can see the cookie dough is changed, or rather was changed to butter pecan. Another thing is that you saw just a little bit ago. There was something called list. Where is it? Something called a list within a list. Basically, a nested list. So we said scoops, spoon, shoe. Let's give this, I would say, that's that. That's that. List underscore lists is equals to. So while we run this, we now have the next step next. If we look at the index, this, look at the index, we say 0, get vanilla. If we say 2, we get coots and spoons. Now, since we are a list within a list, we can also look at the index of that nested list. So let's now say 1. That should give us just 4. And you can go on and on with this. You can do list within list within list, and all of them will have indexing that you can call. So let's come down here to start taking a look at course. So we list in a two bound actually quite similar, but the biggest difference between a list, a tuple, that a tuple is something called immutable. It means it cannot be modified or changed after it's created. So let's go right up here. Let's say tuple. Let's run out here for a tuple. Let's say equal is equals to, let's do an open parenthesis. Okay. Now these open parentheses, you same if you do like a print statement, but that's different because that's executed a function. This is actually creating a tuple, which is going to store aircrafts. So let's say 1, 2, 3, and 1. So let's go ahead and create that. We can just check the data type very quickly. Sorry. Right? That's error. Subtract something wrong. Let's run over that again. Triple. Okay, yeah. Get failure. So you have to keep with failure. So let's run that again. Another data again. Okay, still the answer. Okay. So we have our tuple. Like we saw before, but tuple is also indexed. So if we go please. Okay. So if we go at the very first position, which is a 1, you'll get the output of a 1. But you can do something like, let's say, step and then had a value. Reflect 3. Definitely for effects. Let me say, give the object has no attribute append, because you cannot change or add anything to tuple, just like we were talking about before. Typically, people use tuple for when data is never going to change. An example for this might be something like a city name and country or location, something that would. They definitely have their use cases, but I don't think they're as popular as just using a list. So now let's scroll down, start to get a look at sets. Then we have a few more cells, but so let's say or a set is someone similar to a list in a tuple, but they are a little bit different. For in fact, there that they don't have any duplicate elements. Another big difference is that the values within a set cannot be accessed using an index because it doesn't have an index, because it's actually unordered. We can still look through the items in the set with something like for loop, but we can access it using the brackets and then accessing its index points. So let's go ahead and create our first set. So we're going to say delete on open. Let's say HQ. And to create a set, we're going to use the swing it bracket. Oops. Oh, these actually, I don't think there's actually a name for it, but to take over type of file that's a lesson, let's just call it something. Let's go squiggy, because it's squiggy. So let's put in 1, 2, and 3. So that's why that look type. Sorry. That's then paint. So that's right. as you get said, it's a set. So when we print this out, so print this out, it's gonna be 1, 2, and a 3. And those are all the values within our set. But if we copy this, we will say daily pints log, daily pints log. It is going to be every single day. So, what do you think? Okay. So when we run this, I do the exact same thing. For a moment, set points daily lowered. And our daily unscored log. And when we run this, we do the exact same thing now. We print this. It's going to add just unique values within that thread. Now, a use case set is something like that. So a use case in the for sets is comparing two separate sets. Maybe you have a list or tuple, and you convert that into a set, and that will narrow it down to its unique values. And then you can compare the unique values of one set to the even values in another set, and then we can see what's the same and what's different. Okay, so let's go and say I need on the sport. On stairs. Okay. Alright. Oh, these random numbers. So this is my daily log, and this is my white daily log. Now we can compare these values. So let's go right out here. Let the print to my daily log. To my daily log. Check this. I did log. We'll do something here. Oh, sorry. So we're gonna do this bar right here. And this is going to show us the combined unique values. It's basically like really putting all of them all in one set and trimming it down to just the unique values. So take wax daily paints, log, So all we want is we're supposed to say all the unique value all the time. You can see 0, 1, 2, 3, 4, 5, 7, 8, 5, 12, 34, 31. So these are all the unique values between these two sets. So we can also do another one. So instead of the bar, we're going to do the symbol right here, which is called ampersand. Well, get copy on that. When we run this, it's going to tell us what matches. That means which ones show up in sets. So the only ones that show up on both sets are 1, 2, and 3. So you can also give a -5. It shows what doesn't match. But we have 4, 12, and 31. This one of the numbers that was in our wife's daily paint log. It's in that's 24. That is the wife's daily paints. So when we subtracted the values, so left to refer to this and take daily paint log. So wife's daily paints. Okay. Now, those are our values. So we're taking the values, yes, those subtracting all the ones that are the same and getting all the remaining values. And then for the last one, keep overwriting. So bear with me. Let's roll this again. It's right here. Okay. No softwares. Let's get rid of this. So do this right here. And this is going to show the play value. It's either in one or the other, but not both. That's what it. Those values are completely unique only to each of your texts. Now, the very last one we're going to look at in this video is dictionaries. So dictionaries is the most different out of all the previous data types we've looked at. Within the data types, we have something called a key value pair. That means when we use a dictionary, it's not like a list where we just add value, comma. We have a key that indicates what that value is attributed to. So let's write out a dictionary to see how it looks. let's say dictionary score crane, and just like our SAS, we use it to line. But the thing that differentiates it is that in a dictionary we have that key value pair, whereas in a set, each value is just separate from my home. So let's write name, and this is our key. This is our key, and when we show color, we get our value. So we're gonna say, okay, Alex, a bird. And we separate that key value pair by comma. And then we can do another key value pair. So say weekly page. Okay. And the color and say 5 or it will do portable nine. Favorite ice. Fine. So we're gonna do list. So within this dictionary, we can also add a list. So please. So I'm gonna do else they say for main complete truth. And then we'll add sorry. Ultimate. We have our very first dictionary. So let's copy that's M1. And let's just about a type. Right. Sorry. Sorry, what I was going to bubble with this. Sorry. So, but as you can see, it says that this is a dictionary. Let's also print it out. Now, if we want to, we can take our dictionary crane, pay dot values. With an open parenthesis, when we execute this, we'll see all of the values within this dictionary. Here's a value of Alex Freeberg. 5. So it hits. Can also say Moses. When we run that, all the keys, the main weekly intake and favorite ice creams. Here, we can also say the items. Items. So this key value pair is what I could do. Okay. The key value pair is result one and built items. So this key value pair is one item, right? This key value pair is another item. One difference between something like a list and a dictionary is how you call the index. So you can't call it by doing something like let's this is a key. You can say it is bracket and say 0. It will give it error. Calling dictionary is actually by the key. So it doesn't actually have an index where you can specify what you want to call and take it out. So we're going to say okay, and it's gonna call this key right here. So when we run this, we're gonna get the value and link to it. All right. What other thing we can do is you can update information in a dictionary. Weekly count with some other tape data types. So for this from there, which was Alex framework, right? Let's say framework. I will be updated. Okay. Say frames, dictionary. It's gonna update Crystal Freebird into the value of the man. So let's go ahead and run it. Now change the name from Alex Freebird that we have here to Crystal Freebird. We have it. We can also update all of these values, right, at one time. So let's copy this. Let's put it right off here. Let's take dictionary underscore crane or dictionary dot frame the update. I'm gonna put a parenthesis around that. So now what we're gonna do is update this entire thing. So this dictionary. Now we can update this to anything we want. So right here we can say wait. So it actually right. always, wait, wait a moment. Let's use this. Let's see. Wait. Oops. So let's roll this. And as you can see, it did not delete our key value pair here. Instead, it just added to it. When you use the updates, we can't actually delete. That's the delete statement, right? But all we did was add the new value. So we need to check and see you fixed everything with your key value paste. You can go here. If you want to delete, let's say EL, that stands for delete. We'll declare cream and I'll specify the E, which will also delete the value with it. Let's just find a key that we want to get rid of. Let's say so. Let's print that again. Says error. So we're gonna check what would it with demon and spell it against themselves. Is it? Okay, as you can see, so we love using weekly intake. So delete weekly in. Now, as you can see, weekly input was deleted from that binary. So that's what we're going to be covering in the paper time video. Thank you.
For watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.
Welcome to the Module 4 of this data science course, where we'll be looking into Introduction to Machine Learning under the following units. What is machine learning? Supervised versus unsupervised learning and common machine learning algorithms such as linear regression, decision tree, and so on. What is machine learning? Machine learning is a prominent and powerful subfield of artificial intelligence. Its core ideas revolves around creating systems that can learn from and make decisions based on data, rather than being explicitly programmed for every possible scenario. Coined by AI pioneer Samuel Arthur in the 1950s, machine learning gives computers the ability to learn and improve their performance on a specific task automatically through experience, typically by being exposed to large amount of data. Component of machine learning. Conceptually, the machine learning process often involves several key components, such as data input. Machine learning algorithms start with data. This could be structured like numbers in a spreadsheet or unstructured like text, image, or sound. This data is used for training. Secondly, learning and training. The algorithm processes the data training, searching for patterns, relationships, or underlying structures. It adjusts its internal parameters based on this data. Thirdly, predictions or classifications. Based on the patterns learned during training, The model makes predictions about new unseen data or classifies it into categories. Number 4, evaluation. The model's predictions are often evaluated against known outcomes, if available, using an error function to measure accuracy. Number 5, optimization. The algorithm iteratively adjusts its parameters to minimize errors and improve its performance until a desired level of accuracy is reached. The ultimate goal of machine learning is typically to automate complex tasks, make accurate predictions about future events, or uncover hidden insights within data that might be difficult for humans to discern. What distinguishes machine learning from traditional programming is its ability to learn from examples. Instead of programmers writing explicit rules for every situation, like a detailed recipe, machine learning algorithms learn the rules themselves by analyzing data. This makes machine learning particularly effective for problems like image recognition, natural language processing, or recommendation system, where defining explicit rule would be incredibly complex or impossible. Supervised versus unsupervised learning. Machine learning methods are broadly categorized based on how they learn from data. The two primary categories are supervised learning and unsupervised learning, distinguished mainly by the type of data used during training. Supervised learning. In supervised learning, the algorithm is trained on a dataset where each input example is paired with a corresponding correct output or label. The algorithm learns to map input to output by finding patterns in the labeled training data. The goal is to train a model that can accurately predict the output label for new unseen input data. Analogy. This is akin to learning with a teacher or supervisor who provides the correct answers for examples study. Common task. Classification, predicting or discrete category or class label. Example include classifying emails as spam or not spam, identifying handwritten digits or diagnosing disease based on symptoms. Regression, predicting a continuous numerical value. Example include predicting house prices based on features like size and location, forecasting sales figures, or estimating a person's length of stay in a hospital. Algorithm. Common supervised learning algorithms include linear regression, logistics regression, decision trees, support vectors machine, and random forest. Unsupervised learning. In unsupervised learning, the algorithm is given input data with any corresponding output labels. The algorithm task is to explore the data and find hidden patterns, structures, or relationships within its own without explicit guidance. Analogy. This is like learning by observation, identifying similarities and differences in the data without being told what category or outcome exists beforehand. Common task. Clustering, grouping similar points together based on their features. Example include segmenting customers into different groups based on purchasing behavior, grouping similar documents, or identifying communities in social networks. Associating rule learning, discovering rules that describe relationship between items in large data sets. A classic example is market basket analysis, finding items frequently purchased together. For example, customers who bought diapers also often bought beer. Dimensionality reduction, reducing the number of variables features in a dataset while preserving important information. This can simply simplify analysis, improve model performance, and visualization. Algorithm. Common unsupervised learning algorithms include K-means, clustering, hierarchical clustering, principal component analysis, PCA, and a priori algorithm. Common machine learning algorithms, conceptual introduction. While the field of machine learning encompasses a vast array of algorithms, understanding basic concepts behind few common ones provide a solid foundation. Here we introduce two widely used algorithms conceptually, focusing on their intuition rather than mathematical details. Linear regression, supervised regression. Linear regression is used when goal is to predict a continuous numerical value like price, temperature, or score based on one or more inputs. It is the simplest form. Simple linear regression involves finding the best fitting straight line through a scatter plot of data points representing the relationship between single input variable, for example, our status, and the output variable, for example, our price. How it works. Intuition. Imagine plotting data pointing a graph. Linear regression tries to draw a straight line defined by an intercept and a slope that comes closest to all the points. Closest is typically defined by minimizing the sum of the squared vertical distance, errors or residuals between each actual data point and the line predicted by the model. The resulting line represents the length linear relationship, allowing prediction of the output variable for new input. Analogy. Think of drawing the best trend line through a scatter plot of height versus weight to predict someone's weight based on their height. Use cases. Predicting sales based on advertising spend, estimate crop yield based on rainfall, predicting exam scores based on study. Decision trees, supervised to track classification regression. Concept. The decision trees are versatile algorithms used for both classification, predicting categories, and regression, predicting numerical values. They work by creating a model that resembles a tree structure or flowchart. How it worked in picture. The tree starts with a single root node representing the entire data set. The algorithm then recursively splits the data based on questions about the input features. For example, its color is equals to red, its age lesser than 30. Each question corresponds to an internal node, and the possible answer lead down to different branches. The goal at each split is to create subsets of data that are as pure or homogeneous as possible. Regarding the outcome variable, this splitting process continues until certain criteria are met. For example, maximum tree depth reached, or nodes contained data points of only one class, resulting in leaf nodes that represent the final prediction or classification. Analogy and visuals. Consider a flowchart for deciding whether to play tests. Start with outlook, sunny, overcast, rain. If sunny, ask humidity, I or normal. If I, predict, don't play. If normal, predict, play. This sequence of questions form a decision tree. Use cases. Classifying emails as spam or not spam based on keywords, predicting whether a customer would click on an ad based on demographics, diagnosing medical conditions based on symptoms, deciding loan application approval. These examples illustrate how different algorithms approach learning from data. Linear regression learns a continuous linear relationship, while decision tree learns a set of explicit rules. The choice of algorithm depends on the nature of the problem, regression versus classification, the structure of the data, and desired model characteristics like interpretability. Decision trees are often considered more interpretable than some other complex models. Below the recommended resources for Module 4, articles, videos for further reading. In conclusion, machine learning, which is a subset of AI, enables systems to learn from data without explicit programming. Supervised learning uses labeled data for prediction, classification, and regression, while unsupervised learning uses unlabeled data for pattern discovery through clustering and association. Simple algorithms like linear regression and decision trees illustrate this concept. We've come to the end of the Module 4 of this data science course, where we looked into Introduction to Machine Learning under the following units. What is machine learning? Unsupervised versus supervised learning, and common machine learning algorithms, linear regression, decision trees. We'll be diving into the next module, which involves career in data science.
Thanks.
You're going to be learning about variables in Python, right? In this particular video. A variable is basically just a container for storing data values. So you take your value like a number or a string, can assign it to a variable, then the variable will carry and contain whatever you put into it. So for example, let's go over right here. Sorry. Let's say x, which is going to be a variable is equal to, so we're going to assign our value to about, so x is a variable, we're going to assign our value to it. So let's say our value is 22. X is not equal to 22. So we don't have to write the number 22 in later script that we write. We can just say x, because x is equal to 22. It now contains that number. So we can allocate it then car, and we can say practice. We can open it, we can do a parenthesis, right? It's a print. Complete the parenthesis. And then we say x. I'm gonna hit shift enter. Now it prints out the 22 because we're printing x, and x is equal to 20. This is our problem. And that's a variable. One really great thing about variable is that it assigns its own data. It's going to automatically do this. So we don't have to tell x that it's an integer. It just automatically knows that 22 is a number showing. We can check that by saying type and open parenthesis, type, open parenthesis, writer x. I will do shift enter again. Now it says x is an integer type, right? Now we only assigned an integer to x. Now let's try assign it string value or some text to a variable. Let's say y is equal to main structure table. Sorry. Right. So we say main chocolate chip. Now if we print that again, print open parenthesis y, and do shift enter, it'll print mint chocolate chip. And if we look at the type, we can see that the type is okay. Let's see first. There's a type parenthesis, right? We can see the type is a string this time and not an integer. Now again, we did not tell it that x was an integer and y was a string. It just automatically knew this. So let's go over here very quickly and have several rows in here, because we're about to write a lot of different variables. I really learned in depth out these variables, right? The next thing to know about variables is that you can overwrite previous variables. Right now, we have main triplet dip, and that's assigned to variable y. So if I go down here and let's say print y, and I hit shift enter, it's gonna print out main chocolate chip. But if I go right above it, oh no, please, and say y is equal to, okay, if I print that out, okay, now it's gonna say chocolate, right? Now it's saying chocolate. Whereas up here, that's here, I'm reassigning it to y. It's still gonna say means chocolate. So I come right down here and I copy this and I paste it right here. If you're choosing the right one, perfect. Right here is gonna write y as in chocolate. So when we hit shift enter, gonna write chocolate. Variables are also case sensitive. So if you come up here and I say capital Y, let's see. There's a lowercase y, there's a capital Y. It's going to break up the correct one instead of nomenclature. So I come here, I probably capital Y. It will give us the nomenclature. Up to now, we only assigned one value to one variable, but we can actually assign multiple values to multiple variables. So let's do X, comma Y, moment please. Comma Y, comma Z is equal to assign multiple values to all of those. So we can say, click, color. We can say vanilla, say for paper star. Vanilla, say comma, say work your road, work G, road. Only please. Work your road. Now let's get an unsigned increment to X, vanilla to Y, work your to Z. Ocean Gill is say great. Sorry. Right. Sorry. Oh, please. Okay, that was just type it. I wanted to copy and paste it, but better. It's not seeing it go through. Sorry. Okay, done. Right, brain. Right, so X, Y, Z. Remember, sorry, X, Y, Z. Yeah. Hit enter. It prints out chocolate, vanilla, and buckyroll. These are all three different bags. You can also assign multiple variables to one value. And we can do this by saying X is equals to Y is equals to Z and is equals to whatever we like. So let's do is equal to root BF flow. Almond please. Copy this. So let's fill in our X and Y and Z. Now they are all the exact same. So we looked only on looked at integer and strings, but you can assign things like list, dictionaries, tuples, and sets all to variables as well. So let's go right down here. Let's create our very first list. I'm gonna say it's underscore green a code out eyes. Bring this out variable. Remember, get it to an open bracket like this. In open bracket like this. Okay, maybe just this. And we're gonna for Premiere and copy all of those values. And we're gonna stick it between a minute, please. That's like vanilla rocky world. You don't want to hear it tag it. So we're gonna paste it within our list. Okay, perfect. So now within ice cream, we have three string value: chocolate, vanilla, and rocky road, all within the list. So all we could do is you could say X, comma Y, comma Z, start moments. It's equals U eyes underscore trait. So these three values, chocolate, vanilla, rocky road, will be assigned to these three variables X, Y, and Z. And we can copy the string up here. Like up. Shift enter. Now there was a mistake. So remember this. Right. So let's click. If enter again. So we now have chocolate, vanilla, rocky road. Now, something that we just do, which is really important, or something that you really need to consider, is how you name your variables. So right here, we have ice cream. Now, to me, it's exactly how we should write our variables. There are many different ways that you can write your variables. So let's take a look at that really quickly. Few more. There are a few best practices for naming variables. Firstly, what a lot of people would do, show you some good practices and some bad practices you should avoid doing. So the first thing we're going to look at is something called camel curves. Let's say what a name it. Okay, let's name it camel X, right? Test variable X. Moment. Okay, I'll remember more. Right. Now, if you have a test variable case, the commit case is going to look like this. We have below it is test. We have the upper case variable case. Oh, X is equals to, sorry. This is what those variables going to look like, and we could find it with a little for. Swear. And this is what your camel case will look like into the lowercase, and all the rest of those are compound words, however you say. These letters are going to be capitalized and kind of separate where the words end at the beginning, like full right now here, and copy that. So the next one is called Pascal case. Now, Pascal case is going to look just a little bit different. Instead of the lowercase, our test is going to be in capital P in text. So test. Case. Now, this similar way of writing is similar, very similar to camel case, but just the capital at the beginning. So let's look at the last. It's gonna be the snake. Snake. It's around. Snake. Yes. Now this is gonna be a bit different. The fact that you don't use any capital letters, you separate everything, use it or score. So we're gonna write text underscore. Remember underscore? Variable. I didn't realize that. Underscore. Yes. Let's change that. The variable. You must be sure you have a spelling tag. Now, typically, these are the best practices. These are what you typically want to keep, but probably the best one to use is the snake case right here. What a lot of people say is that it improves readability. And if you take a look at either of the camp case or Pascal case, which you will see people do, it's not as easy to distinguish exactly what it says. And the name of a variable is a plot cycle, so you can hear the condition format if people name them appropriately. So we do not be naming. So when naming the variable, you should write it as snake case because it's easier to read because each word is broken up by the underscore. So let's take a look at the variable names. These are all the words you can use. So that's for introductory test underscore. We could also do what's that, please? Remember underscore test bar. You see that buffer that well people will start using it with an underscore. They can do test var. Okay, please. Remember. You can do test var capital P. Exactly. Capital P, capital C, capital V. Remember that in test bar. Or you can use something like test var. Now adding a number to your variable not inherently a bad thing. Use it. Semi proud point, but there are definitely some use cases where you can use it. But one thing that you cannot do is do something like, say, put it to up a front here. Put it in front, it no longer works. That's the right? It no longer works. Syntax error. If on rough traffic at all, so let's take it out. So we can do that. It is an example of what you should not do. Like that all like you that. Right. Also can use a dash. So something like voltage, test, dash, a peep. That was the word either. You also can use something like a space or a comma. Actually, any kind of symbol, a period or backlash, equal sign, one of those things will work within your variable. Now, another thing you can do within your variable is use the plus sign. So let's assign this x is equals to Woodway strength. It will say ice. And then we'll do a plus sign. What I could do is you literally add these two strings together, right? That's all it's been. Add this string and this string together. So let's do string shit. And now it now says ice cream is my favorite. What we cannot do in a variable, we cannot add a string and a number integer. So we can be ice cream is my favorite. If you try to do that, it will give us this error right here. Sorry, the error, right? So it's error, it says you can only concatenate a string, not an integer. A string. So only a string plus a string for this example. You can also do a factoid. X is equal to high screen. It's the Y. Y is equal to ice cream and ferret out. Y is equal to 3 drops cheap. No, it's sorry. Y is equal to 3 plus 2. Oh no, it says. Sorry. Now it was realized that you actually kept showing ice cream is my favorite. You know why? Because the X it's still reflective of here. And we have Y here. So we have to change this to Y. So let's bring shift enter. Now you can put a 5. You could also do an integer on an integer. Now, so far you've only included one variable in the printing statement, but you can actually add multiple variables within a print statement. So let's go right down here. So we need to have more. Okay. We're gonna say x is equals to x equals ice cream, ice cream, what's that, please? Cream. We're gonna say y is equals to s. I would say d is equals to my favorite. My favorite. So look the bottom, we give it to the correct x. A moment, please. Please, okay, so come to the bottom and say correct x plus y, that's equals to plus y plus z. Don't need enter, hit enter. Well, we're on that. We have ice cream is my first. Now we click add a space before my. I will aid shift enter. Can add ice cream in my favorite, so we can add space 2 in front of this. Okay, can have ice cream is my favorite. You can also do this exact same thing with numbers as well. Let's say x is equal to 1. Oh, number please. X is equal to 1. Y is equal to q. Z is equal to 3. Double. Our results equals 6. Now, one thing I've tried to do was assigned to one string a variable plus integer, and that did not work. But what you can do, you can do something like this. So, x a y is equals less. Let's get rid of the z here. It's lost if they're gonna work, so let's try with that. So we can't contain tonight days. What we can do it in print statements is what we're doing presently is separated by our comma. Let me add this comma, it should work properly. Yes, enter. It has I squared 2. Again, this makes sense. Makes no sense where your I wrote now x, comma y, I squared 2 doesn't make sense where are you able to combine a string and an integer separated by a const. This is the meat. The basics of variables, right? There's other things as well, but some of those things are quite advanced, which will be covered in this particular video, right? Now, these are the variables, or these are the basic things you need to know about variables. Thank you
for watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.
Welcome to Modifying this data science course, where we'll be looking into careers in data science under the following units: career paths in data science, required skills and learning roadmaps, and next steps for aspiring data scientists. Career path in data science. The field of data science offers a wide array of career opportunities across virtually every industry. driven by the increasing importance of data and decision making. While job titles and specific responsibility can vary between organizations, several core roles commonly form the backbone of data science teams. Understanding these roles can help aspiring professionals identify a path that aligns with their skills and interests. Here are a brief description of three prominent career paths. Number one, data analyst. Data analysts primarily focused on collecting, cleaning, analyzing, and interpreting data to extract actionable insight that supports business decisions. They often spend significant time querying databases, manipulating data in spreadsheets or programming environments, and creating reports and visualization to communicate findings to stakeholders. Oops. Common tools include SQL for database query, Excel and Google Sheets for data manipulation and analysis, business intelligence platform like Tableau or Power BI for visualization, and often scripting languages like Python or R for more advanced analysis. Positioning. This role is often considered an excellent entry point into the data field, providing foundational experience in data handling and analysis. Career progression can lead to senior analyst roles, analytics management, or transitioning into data science. Data scientists. Data scientists typically tackle more complex problems involving predictive modeling and machine learning. They design experiments, develop statistical models and machine learning algorithms, analyze large and often unstructured data sets, and communicate complex findings. Their work involves a deeper application of statistical theory and computational techniques compared to data analysts. Tools. Proficiency in programming languages like Python or R is essential, along with libraries for data manipulations, Pandas, NumPy, machine learning, scikit-learn, TensorFlow, PyTorch, and statistics. Strong statistical knowledge and machine learning expertise are required. Positioning. This role often requires more experience than an analyst position, and advanced degrees, master's or PhD, are common, though not always mandatory. Career path can lead to senior principal scientist roles. Specialization in areas like artificial intelligence or leadership positions such as chief data officer, a data engineer. Data engineers are responsible for designing, building, and maintaining the infrastructure and systems that allows for efficient and reliable data collection, storage, processing, and access. They build data pipelines, ETL, ELT processes, manage database and data warehouses, and ensure data is readily available and usable for analysts and scientists. Tools. Key skills include strong programming, often Python, Java, or Scala. Expertise in SQL and various database technologies, both rational like PostgreSQL, MySQL, NoSQL, like MongoDB. Big data frameworks such as Spark and Hadoop. Data warehousing solutions such as Redshift, BigQuery, Snowflake, and cloud platforms such as AWS, Azure, GCP. Positioning. This role requires strong software engineering and system skills. Career progression can involve moving to senior engineer, data architect, or cloud data engineering roles, specializing in areas like big data or real-time processing. Required skills and learning roadmaps. Success in any data science career path requires a blend of technical proficiency and essential soft skills. While the emphasis might shift depending on the specific role. For example, deeper machine learning for scientists, stronger infrastructural skills for engineer. A common foundation exists. Essential technical skill. Programming language. Proficiency in at least one programming language commonly used for data analysis is crucial. Python is widely popular due to its extensive libraries for data manipulations, analysis, visualization, and machine learning. R is another strong contender, particularly favored in statistics and academia. SQL, structured query language, is often fundamental for interacting with relational databases, a common task for assessing data. Statistics and probability, a solid understanding of statistical concepts. For example, distributions, hypothesis, testing, regression, and probability theory is necessary for analyzing data correctly, building reliable models, and interpreting results. Machine learning. For roles beyond entry-level analysis, familiarity with core machine learning concepts such as supervised and unsupervised learning and common algorithms is essential. This includes knowing how to train, evaluate, and potentially deploy models using library like scikit-learn, TensorFlow, or PyTorch. Data wrangling and preprocessing. The ability to clean, transform, and organize raw messy data into a usable format is critical. Everyday skill for working with data. Libraries like Pandas and Python are key tools here. Data visualization. Creating clear and effective visualization, such as charts and graphs, is vital for exploring data and communicating findings to others. Familiarity with libraries such as Matplotlib and Seaborn in Python or tools like Tableau or Power BI is important. Databases and big data technologies. Depending on role, understanding different databases types, such as SQL or NoSQL, is often required. For roles dealing with very large data sets, knowledge of big data tools like Apache Spark, Hadoop, and cloud platforms such as AWS, Azure, and GCP is increasingly valuable. Essential soft skills. Communication. This is paramount. Data professionals must be able to clearly explain complex technical concepts and findings to diverse audiences, including non-technical stakeholders and decision makers. Effective data storytelling. Crafting compelling narrative around data insight is a highly valued skill. Problem solving. At its heart, data science is about solving problems. This requires strong analytical thinking, the ability to break down complex issues into manageable parts, and identifying appropriate methods and resources to find solutions. Critical thinking. Data scientists need to objectively evaluate questions, data sources, assumptions, methodologies, and results. They must avoid biases and challenge findings rigorously. Intellectual curiosity. A genuine desire to explore data. Ask why. Dig deeper than the surface level answer. And continuously learn is a hallmark of a successful data professional. Business acumen. Understanding the context of the business or domain in which the data exists is crucial for asking relevant questions, interpreting results meaningfully, and ensuring that the data work drives actual value. Teamwork and collaboration. Data science is often a team sport. The ability to work effectively with colleagues, such as analysts, engineers, domain experts, product managers. Share knowledge, give and receive feedback, and contribute to common goals is essential. Follow a learning roadmap. Start with foundational concepts. A typical path involves learning a programming language, such as Python, is highly recommended for beginners, followed by essential libraries, such as NumPy and Pandas, SQL for databases, and fundamental statistics and probability. Subsequently, delve into data visualization and exploratory data analysis before moving on to machine learning concepts and algorithms. Utilize learning resources. Leverage the wealth of available resources, online courses, platforms such as Coursera, DataCamp, EDX, and Simple Learn offer structured learning path and certifications. Supplement these with tutorials, official documentation for tools like Pandas and Scikit-learn, books, and engaging with online data science communities. Prioritize and on practice. Theoretical knowledge alone is insufficient. Actively apply learned concepts by working in projects. Start with guided projects, then tackle independent ones. Utilize publicly available datasets from sources like Kaggle, Google Datasets, Search, or government portal, such as data.gov. Analyzing personal data can also be a motivating way to practice. Build a portfolio. Document your project and showcase your skill. Create a portfolio that includes code. For example, hosted on GitHub. Explanations of your process, visualizations, and key findings. These serve as a tangible evidence of your abilities for potential employers. Platform like GitHub, Kaggle, or even a personal blog can host your portfolio. Network and engage. Connect with other data science professionals and learners. Participate in online forums. Attend virtual or local meetups and conferences. And engage in discussions on platforms like LinkedIn. Networking can lead to learning opportunities, mentorship, and job prospects. Embrace continuous learning. Data science is a rapidly evolving field. New tools, techniques, and algorithms emerge consistently. Cultivate a habit of a lifelong learning by following industry blog, reading research papers as you advance, taking refresher courses, and staying curious about new developments. Also, stay informed about ethical consideration and best practices in AI and data handling. The path to becoming a data scientist requires dedication and persistence, focusing on building a strong foundation, consistently applying skills through practical projects, and actively engaging with the field are a crucial step towards building a successful, rewarding career. Below are recommended resources for Module 5. They include career guide, skills list, roadmaps, and portfolio platforms. In conclusion, diverse career paths exist, notably data analyst, data scientist, and data engineer, each with distinct focus and skill requirements. Success requires a combination of technical skills, such as programming, statistics, machine learning, and visualization, are crucial soft skills, and crucial soft skills such as communication, problem solving, and curiosity. We've come to the end of this data science course training where we looked at careers in data science under the following unit: career path in data science, required skills and roadmaps, and steps for aspiring data scientists. This course has also provided a foundational glimpse into the world of data science. The data field is vast and constantly evolving, offering exciting challenges and opportunities. The journey to becoming proficient requires dedication, but the skills learned are highly valuable and applicable across many domains. Be encouraged to continue exploring the topics that captured your interest during this overview. Remember that consistent practice, applying concepts to real data sets, and engaging with the vibrant data science community are keys to growth. Maintain your curiosity, embrace the learning process.
Thanks for watching. If you found this video helpful and you're passionate about learning, don't forget to hit that subscribe button. We share practical tips, deep dives, and step-by-step guides to help you grow your knowledge and skills. You can also visit our website through the link below to access engaging courses. So if you're ready to keep learning and stay ahead, subscribe now and turn on the bell so you never miss a new video. See you in the next one.